Alright, this video is for the Unit 5 test review for the Blended Algebra 2 class. I'm not going to do every problem from the review on this video, but if you have other questions, you can check the key on Canvas or ask your teacher for help. Number 1 through 4 on your packet here, you are allowed to use Desmos. The rest of the packet will be no calculator, and it says that on your paper. So let's start with number 1 here. It says use the quadratic given to you in vertex form, identify the information, and graph it. Alright, so let's try to do some of this just to review the properties without using Desmos, and then we can check our work. The turning point when you're given vertex form is always the opposite of what is in the parentheses, so that would be -7, and then the same number as what's outside the parentheses as the y value. We're going to decide if this is a maximum or a minimum. Well, to do that, we look in front of the equation. Here there is no negative sign, it's positive, which means my graph is going to open up, which then means your graph has a minimum. The axis of symmetry is the invisible line that cuts through the middle of my parabola, and it is equal to the x value of your vertex. Alright, now, that's good. Let's take a look at the picture of this graph so we can plot it and then answer the rest of the questions. So when you get to Desmos here, you're going to type in what you have. So you'll have x plus 7 minus 4. Alright, now you can see the picture here. You really only need a couple key points in order to plot it here. So really you only need these three. I have -7, -4, which I think is what we had at our vertex. Yep. So I'll plot -7, -4. And then we found the x-intercepts were, oh, wrong one, -9 and -5. There we go. So you sketch, it says sketch at least 3 key points. Those would be your 3 key points. You can plot your picture. And it actually helps us find down here the zeros and the roots. Right? Our zeros and the roots were at -9 and -5. The domain, we'll go back up here to domain. Domain, remember, for a parabola is always all real numbers, or you could say from -infinity to infinity. In the range, I start on the bottom. The lowest y value here is at -4, included, and it goes up forever to infinity. So I have those arrows. Now let's go back to y-intercept. I don't see my y-intercept on the graph that I made, so let's look at Desmos. I am actually going to have to, I'll just zoom out here. Zoom out, I'm looking for where I cross the y-axis, which when I click on it gives me 0.45. Alright. Now, let's talk about the bottom part here, standard form. ax squared plus bx plus c. Oh, I wanted to show you the equation of the axis of symmetry. I can check that by graphing on Desmos. If I graph the line x equals -7, you should see that that is that blue line that goes right through the vertex and the middle of your parabola. Alright, so standard form, thanks, I'll get that in a minute. We're going to turn this vertex form into an equation that has no parentheses. So if I start here with x plus 7 squared minus 4, the way I get that out of standard, or vertex form, I'm sorry, is first I have to get rid of these parentheses. Now I have to remember, I have to rewrite this out as x plus 7 times x plus 7 first. You can't just square the x and the 7. You actually are going to have to FOIL here. So you will have x times x, which is x squared, plus 7x, plus 7x, plus 49. And then on the end, you'll have -4. So when you combine these like terms here, you'll get x squared plus 14x, and then 49 minus 4 is 45. Now before we move on, notice that the number on the end of our standard form was the same as our y-intercept. That should always be the case. Alright, transformations here. Get those from vertex form. So when I look back up at my vertex form, right up here, the plus 7 inside the parentheses means your graph went left 7 units, and then -4 on the outside meant it went down 4, which I can see. My vertex is usually at 0, 0, and it's at -7, -4. It would be left and down. All right, the next one we're going to look at is number 3. All right, for number 3, it says we can use Desmos for this as well, so we can check our work. So find the vertex of x squared minus 6x plus 11 using the formula the opposite b over 2a. All right, so you need to know what a, b, and c are in order to use this formula. So remember, a is the number in front of x squared. Here it's a 1, b is -6, c is 11. Now to use this formula to find the turning point, it finds the x value of the turning point. So you're going to take the opposite of -6, which is +6, divided by 2 times 1. That equals 3. That tells me my turning point, my vertex, has an x value of 3. To find the y value, you're going to substitute 3 in for x. So we'll have 3 squared minus 6 times 3 plus 11. Now, to do that, you can just go ahead and type that expression into Desmos, and it'll calculate the value for you. So we'll have 3 squared minus 6 times 3 plus 11. And that tells you the y value is 2. Now, if you wanted to check your work, you could go ahead and graph the equation in Desmos. 8x squared. You see that the turning point here is at 3, 2, just like we had. Now, the graph here we can see has a minimum value. You could also tell that because the x squared here is positive, you know the graph will open up and it has the lowest point. The axis of symmetry is always x equals the x value from the vertex. Again, if you wanted to check that on Desmos, graph with the graph here, x equals 3. You'll see that that line goes right through the vertex in the center of the graph. What's the y-intercept? Well, when you're in standard form only, the y-intercept is the last value. It's where x equals 0. 2 ways we can use this on Desmos. We can either click on the y-intercept, or we can make a table and look where y equals 0. You'd see that you get 11 there. All right. Last one. The vertex form is x minus 3 the quantity squared plus 2. What transformations have happened? Well, we had a -3 in the parentheses, which means you went right 3. And the +2 on the end means that graph went up 2, which I can see on my picture. Usually my vertex is at 0, 0. Now my vertex is over to the right and up. Okay, the next problem on the review here is going to be number 5. This is the no calculator part of the review. State the vertex from standard form and then list the transformations that have happened. Well, the vertex here, you take the opposite of the number in the parentheses, which here would be +2, and then the same as the number on the outside, 2, 1. The transformations, you start on the left. I have a 1/2 in front of the entire equation. 1/2 is less than 1, so you're going to have a vertical compression by 1/2. Your graph is getting shorter. The -2 inside the parentheses means you went to the right 2 units, and +1 on the outside means you went up 1. And that was 5a. Now we're going to look at 6, which is a multiple choice question. 6 says, which of the following could be the quadratic to the right? This is no calculator. First thing I want you to notice about the quadratic to the right is that it is upside down. That means that it was reflected over the x-axis, so it's upside down and has a negative in front of the entire equation. I can eliminate C and D because these are both positive, which means their graphs are going to open up. I want a graph that's going to open down. So I'm eliminating down to A and B. Now the next thing I would do is notice where the y-intercept is. This y-intercept is a positive value. In standard form, the y-intercept is the constant on the end of the equation, which the other one here, only one that matches, would be B. All right, now we're going to look at number 8, another multiple choice. We're given a parabola. What is the domain and the range? Well, notice on the end of this graph, there are arrows. And when you have arrows going to the left and the right, your domain is going to be all real numbers. I can automatically eliminate B and D. I want negative infinity to infinity. Now my range goes bottom to top. Now here I'm looking at the y value on the bottom, which is at negative 4. I'm going to go from negative 4 up to infinity, which matches with C. All right, next we have number 9. 9a. We're going to write an equation that's undergone these transformations. All right, so if we're going to reflect over the x-axis, we start our equation with a negative out in front. Left 2 units. Left is going to be inside the parentheses here with the x. Now if I go to the left, that ends up being a plus 2. And finally, up 7 is outside of the parentheses. We put a plus 7 on the end. Now we're looking at 10c. So you're given a graph. The red graph here is your parent function. The blue graph is the transform function. So let's state the transformations first, and then we can write the equation. First, since the blue graph is upside down, that means it was reflected over the x-axis. Next, it looks like my graph went up 9 units. It's not at the origin anymore. And finally, we have a stretch. Right? My regular parent function, I go out 1, up 1. But in my blue graph, I go out 1, down 2. I'm 2 times as big, so this is a vertical stretch by 2. To write this equation, I would have y equals the negative for the reflection comes first, then the vertical stretch. I didn't go left and right, so I don't need parentheses around the x this time. And up 9 is going to be a plus 9 on the end. All right, we have one more problem to go. I think we're just going to do, number 12. And then we will go ahead and be finished with the review here. This one, you're given the parent function. You need to state the transformations and then make the graph. The negative in front means you were reflected over the x-axis. We just talked about that one. Okay, so your graph's going to be upside down. The 3 in front is a vertical stretch by 3. The 3 is greater. The absolute value is greater than 1, so it's going to be a stretch. And then the 4 on the end is up 4. All right, so if I darken in the points of my parent function here, when I reflect them over the x-axis, the pattern is going to be the same. Out 1, down 1, out 2, down 4, just the opposite direction. Now we're upside down. Okay, so I have darkened those. My reflected graph. Now vertically stretching by 3 means all my y values are going to get bigger by a factor of 3. My first y value is at 0. If I multiply 0 by 3, it doesn't change. My next y values are at negative 1. If I multiply negative 1 by 3, I'll be at negative 3. So my points will be at 1, negative 3, negative 1, negative 3. The next one, 2, negative 4. If I multiply that by 3, I'm actually at 2, negative 12. That's off the grid, but I'll plot it anyways. So here, that's all that's going to fit. That's my vertically stretched by 3 graph. Now all I have to do to move my graph up on the last one is just take each point and go up 3. So instead of 0, I'm going to be at 3 here. Here's my next point, 1, 0, because I moved these dots up 3. And then instead of 2, negative 12, I'll be at 2, negative 9. All right, and that would be your final graph. If you have other questions on the review here, check the key on Canvas or ask your teacher for some help.